Hi there, it's Darren O'Neill from Darren's Tech Tutorials and darreno'neill.eu. In this short video, I'm going to give you a really simple overview of what load balancing is and kind of explaining some of the key terms of load balancing. So what I have here in this diagram is I have a fairly standard setup that you would see. So what we're going to do is we're going to cover what is load balancing, we're going to cover how load balancing gets configured, some of the key load balancing algorithms, what is a health check, and what is stickiness. So this is a key thing that you'll see an awful lot in diagrams. You will have your users over here, and they'll come in and they'll hit a load balancer. And then generally what you'll see is the load balancer will distribute the load across 3 servers. And then normally you'll have a stateful database that sits behind these servers, and then the 2 databases communicate to one another, and they keep state. And since there's 2 of them, they're kept highly available, and they hold the state of the application. So you might ask yourself, how does all this work, and how does all this get put together? So normally what happens when things are being deployed, you'll get a load balancer. Now, if this is on-prem, it could be a tool like an F5 load balancer, or if it's on AWS, you could be using something like an application load balancer. So this sits in front of your infrastructure. So normally you'd put your URL on this, so it might be test.com. So when your users make a request to test.com, they hit the load balancer. Now what the load balancer does behind the scenes, it has a couple of servers. So it may have server 1, 2, 3, and all the way up. So what will generally happen is user comes in, makes a request to test.com. Test.com hits the load balancer, and the load balancer makes a call to one of the web boxes. Now, if you're using like a standard 2-tier application, you will normally keep your state away from your web instances, because if you hit here and then you hit this one next time, your state is gone. So generally your state is stored back in a database back here. So if you were logging into a website and you wanted to make sure, for example, I was D O'Neill, you would need to make sure you come in, you hit the F5, you hit the standard one of the boxes here, and it doesn't matter which one you hit, because generally you come back here to get all your state and get all your information. Now you see we have 2 databases here, but generally these are configured in like an active passive mode, and they're usually done in some sort of DNS failover. So what that means is all the state is stored here, and it gets written over this other database, usually in a synchronous write, so it's done pretty much instantaneously, and these 2 databases keep each other up to date. And if one of these happens to go down, there's usually some logic here, usually done by DNS. So if you imagine you have, let's say this is db.com, and your DNS is constantly saying, are you okay? Are you okay? And if it says no, what happens is it swaps db.com to this database. So now if you come in with D O'Neill, you hit this server, you now get directed over to this database. And because all the state is transferred in a synchronous write, it has all the key information that you need. So that's at a high level how all this hangs together. So let me clear the screen here so we can go back. So we want to know, like, I suppose, what is load balancing? So load balancing is a way to distribute the load across multiple servers. So why would you want to do this? Generally, you do it for a few reasons. You'll do it for performance, to make sure you get the perf you want across the systems. And you also do it for HA, for high availability. So if we only ever had one server, if that one server fails, our application is down. But in this configuration, if we lose one server, we are actually still up. We actually still have 2 other servers, and we can actually lose 2 servers. And the request will come in, and we're still up because we'll get directed to here. So that's why you'd want to do load balancing. So generally you do it as you want to make sure that you have multiple instances of your site up. So if you ever lose one server, your other servers are still up, and it gives you a greater highly available web application. Okay, so you might ask, what about this load balancer? Well, if this fails, so what happens in a lot of places is they actually have 2 load balancers. Now, if you're using AWS or something, or you're using an ALB, an application load balancer, this is actually abstracted away, and you kind of get 2 by default. But generally how this works is usually with some DNS trickery is how this normally works. So what will happen is, say again, if we go to our, say, test.com, and this is attached to our load balancer, normally it is some sort of DNS health check that will say, are you okay? Are you okay? And if not, it will send you to here. And then again, you still have your multiple nodes behind the scenes that keep you up. Okay, so that's pretty much how load balancer is configured. So normally it is configured with a load balancer, and one or more web nodes, and then usually a place for holding state, and this is normally a database. So again, as we talked about momentarily ago, if you have D. O'Neill, and if D. O'Neill only lives on this server, you're in trouble, because you can have pretty much this user coming in, and instead of getting directed to this server that they normally go to, they get directed to here, and D. O'Neill doesn't exist. And then your users will have issues. So it's important that you always store your state in a centralized point that all your load balanced servers have access to. And that's pretty much how you configure load balancing at a high level. That's how load balancing gets configured. Okay, so you might be asking, how does the load balancer decide how to distribute its load? And there's a couple of algorithms, and I won't cover all of them, but I'll cover maybe one or two of the most popular ones. So one that you hear a lot is round robin. So pretty much let's put OR for round robin. So pretty much what the load balancer will do, it will send one request to this server, the next request will come in, I'll send you to here, and then the next request will come in and it will send you to the third server. And it just continues on like this. It is how it will send the load when you're using round robin. Now there's some other ones you can use. So you can do, for example, least utilized. So the load balancer is clever enough to check, okay, so you're at 90% CPU, you're at 80% CPU, and you're only at 60%. So the load balancer will look and it will send a request to here. So that's another way that the load balancer will share its load amongst the machines. Another way it can do is called Lease Connections. So what it will do is the load balancer will look and it will say, okay, there's 100 users here, there's 80 users here, and there's only 5 users here. So the load balancer will say, I'll send the user over to this server as it has the least amount of users on at the moment. Okay, so you might ask, what's a health check? I hear health checks a lot when I'm dealing with load balancers. So this is a really important piece of load balancer technology. So generally what the load balancer will do, it will say to the server, are you okay? It will say to this server, are you okay? And it says to this other server, are you okay? And it does this, multiple times a minute, and it just checks with the servers. And normally the servers will go, yep, I'm good. The other server will go, yep, I'm good. And the other server will go, yep, I'm good. And this kind of communication happens back and forth. And what this means is that the load balancer knows when user comes in, you've told me you're okay, I'll send the load onto you and you'll look after it. So that's kind of what health checking is. So you can health check on a couple of things. So you might do HTTPS operates on port 443. So you might just do a simple health check that will say, is port 443 listening here? Is port 443 listening here? And is port 443 listening here? And then if it's all okay, the health check's passed. You can even do some more complicated things, like what you could do on your application. You may actually have a page in your application called health check. And what will happen is on the health check, it will say, I'm okay, or something along those lines. It will say, I'm okay. And the load balancer will check and say, are you returning I'm okay? And if you're okay, I'll send load to you. So pretty much what happens if one of these health check fails? So the load balancer goes, are you okay? And this guy says, yeah, I'm okay. The same happens here. This guy goes, yeah, I'm okay. And it comes down here and says, are you okay? And the load balancer hears nothing back. So pretty much what will happen is the load balancer will just stop sending requests. So user 1 comes in, will get directed to this server. So we're just doing round robin here. User 2 gets directed to this server. User 3 gets put back up to this server up here, and then this server is completely out of the equation. So that's pretty much what health checking does within the application or within the load balancer. Okay, so the last topic we're going to cover here is stickiness. So you'll hear stickiness being branded around a lot when you are talking about load balancers. You'll hear, is stickiness enabled, or do I need stickiness? And you might be wondering what that is. So here we have user one, user two, and user three. So let's say we're user one and we come in to the application. Now, as mentioned, all the state is normally stored within the application. So all the state is normally stored here. So anything that's really, really important. But sometimes you might have applications that say, for example, store a login cookie on the actual server itself. So it's not really stateful, but you want it stateful for that session because you don't want user one, when the login cookie is created and stored here, you don't want them to end up back on this server over here and then they get asked to log in again, so that won't be a good experience. So when you enable stickiness, you enable a bit of intelligence on the load balancer that says whenever user one comes in, so user one, I've recognized him, I want his session to be sticky. So he always goes back to this box. So user one, every time when he's going into the application during his session, he'll always get directed back up to the server one. He's always sent back here because we have stickiness enabled. So user two comes in and we have stickiness enabled and they go to this server. And again, they always return to this server. So that's what stickiness enables. So pretty much this was a high-level overview of what is load balancing, how do we configure load balancing, what are some of the load balancing algorithms, what is a health check, and what is stickiness. It's a very high-level overview, but hopefully it will give you the knowledge that you need to know if you're in a meeting, being able to speak to load balancing with some comfort. And please do comment below if you had any issues, and if I can help, I certainly will. And thank you for watching.